All right, I have returned. We are going to make this turret turn towards the enemy. Hold on one second. Fix the mic. Always fixing that mic. All right, so how is this going to work? So right now, yes, this script, shooting obstacle. Can we just attach a different script? Basic turret. Okay. But this basic turret extends our obstacle, what's it called? Entity? Shooting obstacle? Yeah, so because we made one thing a tool, then all the other things have to be. So this will be basic turret. Yeah, I don't know. Let's start with that, right? So that's gonna not break anything. Maybe. Let's reload the current project. Yeah, save and close. Okay. Okay. Not getting a bunch of warnings now. What's this complaining about? Mesh instance 3D not assigned. Oh, we lost things. That's fine. Just fix it again. So I guess when I asked about saving, it didn't actually save. So yeah, now this is using our basic turret script. Okay. So good. What's this? Okay, that's... Oh, I see. That's the... This is the preview of the sprite, the billboard sprite for the health. Sure. Okay, that's fine. What do we need to do? So we need a way to do things. Very specific. What do we need to do? Well, ultimately, I want to be able to change the rotation of the top mesh, right around the y-axis, like that. That's really all I want to do, is I want to be able to change this in response to what we're aiming at, and I want to have an idle animation. Ooh, maybe we should start there. We could start with what's that gonna work? Is that gonna work? I guess we could have an animation. We need an AnimationPlayer node. Okay. New animation. Idle turret. Okay. Add track. This is a 3D rotation track for the top. Now, I've never tried to do this before. Okay, oh, I see. So we can like insert keys and stuff, right? So if we go to... Yeah, great. Insert key. And then how do we change the length? Is that? And it should be a looping animation. So is this we have to rotate the turret and then but you have to rotate the turret. And then insert a key. Is there a hotkey to insert a key? Boop, 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 boop. Okay. Nope. Okay, fine. Be that way. Yeah, I need to remember to... Hold on. First of all, is this working? Seems like no. Seems like no. Okay. What am I doing wrong here? Oh, I can just change... I don't have to change the value. I can just change this here. Right, so we're rotating around the y-axis. Does nothing. Does nothing. Okay. Interesting. Interesting. Right, so if this is here, and this is here, you would think this would interpolate between those two values, but that doesn't seem to be working. Linear. Okay. I mean, really, if we're having a loop, then it should go to there and then back. Turret top. Rotation. Oh, maybe that... What does the value need to be? What is the Oh, well, that's scale. This is degrees, right? So what we want to do is we want to go to here, and it should be like 180 degrees. Does this work? Doesn't seem like it's working. Oh, what was that warning? Did we see that again? Idle animation 3D row contains unnormalized quaternion key. What does it mean? Oh, this? Aha. Sure. That's fine, right? Temporary Euler may be changed implicitly. Okay, cool. Does this work? Yeah. All right, so that was it. Cool. All right. So we just need a few different keys here, and we'll have some different rotation. Why is there a line between those two? Because they're the same, maybe? Okay, so we want to click this, and then we can change that. And then we have to click out of here. Okay. Why? Oh, right. So maybe because this one isn't normalized? I don't know. Why? Okay, so like that works, right? But between these, it doesn't work? Why? What does it mean? Contains unnormalized quaternion key. Okay, great. Tell me more. Which of these is not normalized? And why? Okay, well, whatever I did, it works now. Okay, great. So can we, what does this look like? We're just like, the whole point of this is just like an idle animation. The turret is scanning around. It should do a 360. So we're only doing like a 180 here. There should be a little bit more going on. So like maybe if I duplicate this key and bring it over here, and this one can be, hold on, let's do like, have it go all the way around. Yeah, so what does that look like? That's great. Faster might be better. Right, so like right here. Have it change. What does this look like? Kind of a slow scan there, and then back, and then through, and then back around. If I were to, hold on, first of all, can we just take all of these and we just move them a little closer, and then just decrease the size, the length of the animation. Right, and then it all happens much faster. What if we change some things around here? I like that it is kind of just a continuous in one direction movement. And it should have varying speeds. Yeah, this is fine for now. Let's stop it. Okay. So that's cool. This is part of what I wanted to do. The other part is that I wanted to aim at enemies when it's shooting at them. Theoretically, I would want it so that it doesn't start hitting, like, damaging enemies until it's aiming at them. But that can be a stretch goal, if you will. Like we can do the aiming part first, and then see if we want to go further. So what we'll do is we'll look at, we have the shooting obstacle thing. We have a thing where we find the nearest enemy, right? And then we perform an attack in the shooting obstacle class we have here. I could do a few different things. I could maybe just save the nearest, like the enemy we're currently attacking, and save that in the class, and so we would have that in basic turret. And then in our process method, we could update the rotation. I kind of like that. Let's do that. So we're gonna have a var current target. Yep. And then we're gonna change this to be current target. And then replace all the things that said nearest enemy to be current target instead. So now, when we have identified an enemy we're going to attack, we save that as a member variable on the class. And then in process, what we want to do is we want to what we want to do is we want to say export var rotation speed is interesting. We might want that, although not. Yeah, that's fine. We want on ready turret top mesh, right? The part that's going to rotate, and that's going to be, what do we actually have? Boop, 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 boop. Turret top, right? And what we want to do is rotate the turret top towards the current target if exists. So is valid instance, I don't think is a thing, but yeah, target direction, current target global position minus the position. Let's see what it's gonna do. This is interesting. No, maybe. I don't know if that'll work, but that's fine. We'll just say if there's a current target, we figure out the direction from the turret to the target. We get a basis. Function looking at is a static function was called from inside an instance. Yeah, that should just be that. And then we figure out the current basis of the turret. And we go from current to target relative to the rotation speed and the elapsed time between process calls. I could almost believe that's accurate. The thing that we're not doing right now, let's turn off autoplay on the idle. The thing that we're not doing right now is we're not switching between being idle or not. Let's test that bit of code to see if it works, and then we'll add the bit to switch between the idle animation and not. Right, so if we start game, we play the base scenario, we put a turret in, doesn't do anything. Oh no. Okay. So I think one thing I want to do here to make it easier to test this is I can make the turret do no damage. Right? We'll just do the damage amount to 0. Okay, something is happening. Something happened. It's interesting. It's interesting. That is something. Okay. We are doing interesting things here. I don't think this is the correct way of doing this. Let's start with logger.info and just do that and see what that's doing for us. Right? Okay. Actually, multiple turrets is bad. Okay, so then we get a value. Current target direction. What does it mean? Right? It's a vector. It is a normalized vector, as in a vector whose length is 1 in the direction from where the turret is to where the target is. So it's challenging. Just because the coordinates are wonky. X. I guess actually, hold on. Go back to there. Right, so the X and Z are not this way and this way. We've rotated the world, right? So let's see if we go back to this. Hold on, can we open the scenario 1? There we go. So is it X this way? I think it's X this way and Z this way. That's interesting. So if we resume, and eventually the zombie here, let's just get rid of that zombie. There we go. Could we? Ooh, let's do this instead of trying to figure out numbers. Draw a line in the world to visualize targeting. Did I mean to use red? Probably. There is no debug draw. Oh no. Why did I think there is? Okay, now we Google. How do we actually do this in Godot? Godot draw line. 3D. Four years ago. Yeah. For debugging. Aha, so there's an add-on. And that's kind of what that was talking. That's why Copilot suggested that. Here's a thing from 8 years ago. Might not be relevant. Wrong kind of debugging. What about... But I want to do this. Not using debug draw. Nonsense. No, 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 no. I mean, I guess I could look at the add-on. It's an add-on for debug drawing in 3D and some 2D overlays. Might actually be helpful. There's some screenshots too. Look at that. I guess I don't really take advantage too much of the asset lib stuff, do I? There it is. Restart the editor after installation. Yep. Add-ons, adds debug draw 3D, and a bunch of things, and install. Okay. And then, well, I did say to reload the current project, so we'll try that. All right. Now, debug draw is not a thing. Maybe debug draw 3D. And again, okay, so we actually have a draw line function from a position to another position with a color and a duration. That's interesting. Let's see what this does. Okay, that seems good. And then it's gone. I guess it's too far. Okay, well, anyway. I mean, that establishes that we can get the position of the two things, right? But what we want to do... I guess what I wanted to do was I wanted to... what did I want to do here? I mean, target direction is going to be that. Ooh, you know what we can do? Let's do export var debug draw. Yeah, that's good. Now, I think a thing that I might want to consider is not having this kind of flag on an individual node like this versus having like a global flag. But it's fine for now. It probably defaults being false. Okay, so rotation to target. We only want to rotate around the y-axis. Like, we don't want it to aim up, down, to do weird things. So this should just be an int. So let's see, Copilot is suggesting turret top mesh at global transform basis Z, angle 2. Is it Z? It's not Z, right? It's Y. And it can be a float, not an int. Max rotation is rotation speed times delta. Okay, sure. Clamp the rotation to the max. Okay, so no, we wanna slurp. No, we wanna not slurp. No. Lerp angle? Ooh, what is lerp angle? Linearly interpolates between two angles and radians by a param weight value between 0 and 1. Similar to lerp, but interpolates correctly when the angles wrap around tau, which is 2 pi. Neat. Okay, so radians per second, sure. Radians per second is a weird input value. This should be degrees. Which I don't know if 5 is a reasonable amount. 90 is definitely too much. Maybe like 12 and a half. I don't know. Okay, so the max rotation is that. We want to rotate towards thing. So rotation to target is how much we are trying to get to, right? From where we are. So we would, our current rotation. Okay, what is our current rotation? Is maybe that. Now that's a okay. How does any of this work? Ooh, global rotation degrees. Okay. Also, do that. Yeah. Right, because this is gonna dot y. Yeah, I know it's a float. Okay. Okay, what do we think about this? It's wrong. Okay, can you stop? There we go. All right, so from to weight. What is weight here? Is this what I want? Okay, rotation to target. Actually, we want to do rad to degrees of this. Okay, so we're going from current rotation to target, because this is the number of degrees of rotation to go from where we are to where we need to be aiming at the thing. And then if rotation to target is 45 degrees, then we want a weight that is 12 and a half divided by 45, so some fraction of the total amount that we need to rotate. that is clamped between 0 and 1. Yeah, I think maybe this is a legitimate thing that we want to do. And then we want to say turret top mesh global rotation degrees y equals lerp angle. I don't know if that will work. But again, this is also, I don't know why I'm in Blender. Where's Godot? There it is. Not a thing I've tried to do before, so how exciting. It's not rotating, so we know that much. It's not turning. Huh, okay. But why? Is it? I thought I saw a little bit of movement. Okay, let's add some debugging. I mean, also I didn't do the one thing that we set up, which is that in basic turret on this, I can turn on debug draw. There we go. So let us logger.info rotating turret towards target. Current Y rotation is that. Target position. Keep on going. Top position. Angle to target. Debug all the things. Okay. Yes, and we'll make these all info. Just that's fine. We log it debug. We show debug level logs. So let's run this, and it's gonna be a lot, but that's fine. There we go. Pause. Yeah, it's a lot. So you can see the debug line that's been drawn. We can see, okay, rotating turret towards target, current Y rotation, negative 0.011473. Interesting. Target position, turret top position, angle to target, 116 degrees. That's an interesting amount of rotation. Max rotation, this frame. Okay, so one thing we need to do if we're gonna do debugging this way. So this is a position. I think what we should do for these two position things is actually do move this down here. So these will be together. Draw indicator of current turret of current turret facing direction. Do we want to do that? Current Y rotation is interesting, right? So current Y rotation is this number is very small. If we look at the remote scene tree and we look at the enemy, not the enemy, the placed turret, wherever that lives. Oh, it's right there. And we look at turret top, and we look at its rotation. It's 0, right? It's 0. Which you can't really see, but just take my word It's below the keyboard, but it's 0 on the remote instance, which means it's not changing. Oh, it does change a little bit. So we have some kind of, like, we are changing something. So that's true. Current turret rotation. Around y-axis. So in debug draw 3D, what can we draw? We can draw an arrow. Why would we? Okay, so an arrow from to. Global transform basis Z is weird. Okay, let's not do that. What are things that would be helpful to hear for me to understand what's going on with this? I don't know. I don't know if there's anything else that's going to help me here that wouldn't be more complicated to draw than just solving the problem. All right. So target position, turret top position. Now, do we think these are accurate? Right. So if we look at this, turret top position, -36, 3, -10. Target position, -18 to -13. Right, okay, so what we're saying is X is this way, and Z is this way. I can believe that. Angle to target 94 is interesting, because the angle should be approaching 0 here, right? So when we're here, we're not seeing any debugging. Hold on. Let's do this. So pause. Okay, there we go. So there's a max distance there on when things are happening. Okay, so rotating target rotating turret towards target. Apparently a tongue twister. Current Y rotation, basically nothing. Target position, turret top position. Right, so the zombie is above, forward of the turret. The angle to target is 102 Y. And the max rotation in this frame is tiny. I mean, that's fine. Per frame would be fine for it to be small. Angle to target is interesting. Angle to target. Right, so that's rotation to target, which is turning radians 2 degrees. Okay, this returns a value in radians. So should we question for you. Can we do something like this? So transform, so it would be like basis dot angle 2. No. Okay, turret top mesh dot. Does this have an angle too? Global transform basis. It's very interesting. This is not at all what I want. Maybe it's Googling time again. Godot, angle to rotate to on y-axis to face object. Hey, how do I rotate an object over time to face a target? It's a Reddit post from 3 years ago. Look at is a convenient way to point an object towards a target. Automatically calculates the necessary rotation, right? So you could do that. Right, so if we just do... If we forget all of this, here's a question. Can we just say turret top mesh dot look at the current target? Now, I don't think this works. Rotates the node so the local forward axis, negative z, vector 3 forward, points towards the target. If param use model front is true, the positive z axis is treated as forward. We have an up vector. What we don't want to do is actually do this immediately, though. Yeah, it has to be in the scene tree. Is there a look at that smoothing? Lerp angle or tweening the rotation Y value instead of directly setting it? Sure. That's what we were trying to do. Let's check out that. And that post as well. And probably look at 3D transforms because clearly I need to read that documentation more. Yeah, you can lerp or tween between a current target and the actual position. Simply use look at. But what if you want to only rotate on one axis? I don't think we can use look at. I mean, we could. We would just have to... Well, look at takes it does take a vector. So what you could do is you could be like, take the target and figure out the equivalent position on the plane of the turret, and then interpolate between the current direction we're looking and where it is. It just seems so much easier to do the thing I was doing before, except it wasn't because angles are hard. Right, so here's an example. Look, follow, up direction, current direction. I've never seen X form before. Blah, blah, blah. And just the direction. Oh. Yeah, you'd think something like that would work. Here we go. It's using... Yeah, I should read the stable version of the documentation. Oh, good. And it kept me on the same page. 3D transforms are a thing. Yep. Euler angle things. You should not use the rotation property of node 3Ds and nodes. Yep. transforms basis. Okay, here's an example. It's possible to rotate a transform by multiplying its basis by another, or by using the rotation methods. So we have an axis, we have a rotation amount. We can rotate the transform around the x-axis by 0.1 radians by creating a basis, or using transform.basis.rotated axis and rotation amount. Okay. So why can't we just... I mean, we need this angle. That's the rotation amount. Bar. Yeah. Get rid of all of these things. Then we say turret top mesh dot transform. Yeah, dot rotated vector 3 up degrees to radians, right? So all of this stuff was in degrees, which I think is a mistake. If we just do global rotation.y, this will be radians. We will take this and keep this also as radians. I don't know what all that is. Turret top mesh global transform basis z angle 2 returns the unsigned minimum angle to the given vector in radians. Interesting. Okay. But why do we need to do that? Like, we should be able to arrive at that from target direction. Oh, wait. I see. No, I don't see. Oh, right. So the direction is the direction, but we're angled whatever angle we're currently at, which is current rotation. Wait, so why do we need all this then? Why don't we just bar target target yaw. That is actually maybe the thing. Everyone remembers ATAN too, right? Target direction X, target direction Z. Yeah, yaw is the term, right? For this rotation. Yeah, anyway. I think that's right. And then we have a rotation speed in delta that signifies max rotation. Rotation amount is lerping from current rotation to target yaw. Right? Because that's just undoing the thing we already did. And we do that. And then target yaw rotation to target, or like this is how much we need to move. This is how much we can move. So this gives us a relative amount that's clamped between 0 and 1. And then we rotate around the positive y-axis rotation amount per frame. Bets on whether or not this will work. It does something. It's spinning. Did we miss some conversion? So this will be radians, and this will be well, this will be a vector, but this will be radians. This will be radians. Rotation speed is in degrees, so this needs to be deg to rad, like so, to have a reasonable rotation speed. And so this will be radian. Okay, so that might have been an issue. Maybe I'll reload. And maybe we can see this before we have to take a break. Come on. Alright. Okay, I'm gonna take a break here. Figure out. We're gonna figure out what I'm missing. But it's feeling much better than when we were like half an hour ago. So take a break here. I'll be back in a couple minutes. And